All right, greetings everyone. Welcome to the third part of the video for section 8.1. This will be our final one before we move on to the other formula we'll be looking at in this section. All right, so let's go back to our UFO problem because I know I left you hanging back a couple of videos ago because you really want to know at what height this UFO is. And so remember, we have the situation where two radar stations are located 20 miles apart. They both detect the UFO. One has an angle of elevation to the UFO of 35 degrees. One has an angle of elevation of 15 degrees. And we need to find the altitude of the flying object. So we're trying to find this right here. So I'm going to call that H again. And if you recall, one of our issues for solving for H before we knew the law of sines was that when we formed a right triangle, like say this one here, well, we didn't have the lengths of any sides, right? We knew the measure of this angle here, but we didn't know the length of this side or this side to help us find that length H. Okay. Fortunately, though, the law of sines will allow us to do that. So first of all, notice in this triangle, we know the measure of this 15-degree angle here, this 35-degree angle here. We can use that information to find the measure of this large angle right here below the UFO. So we can use the fact that the sum of the angles in a triangle is 180 degrees. 15 plus 35 is 50, which then if we subtract that from 180, we get that the measure of that angle is 130 degrees. And notice now we have the measure of an angle and the length of the opposite side, which means we can use the law of sines now. And so we're going to use this to find the length of the side opposite the 35-degree angle. So we're going to set up sine of 130 degrees over 20. So that's the length of 20 miles is opposite that. And I apologize for those lines. I'm not sure where they're coming from. Equals, again, the length of the measure of the angle we're working with. So that's sine of 35 degrees. I'm going to call the side opposite it A. We need to find A. So we do that by multiplying by A on both sides. So then we would have, after these cancel, A times sine of 130 degrees over 20 equals sine of 35 degrees. And then we can multiply by 20 on each side, divide by sine of 130. And so what we'll end up with is the value for A is equal to 20 times sine of 35 degrees, all divided by sine of 130 degrees. Okay. And if we plug that into our calculator, what we end up with then, again, making sure your calculator's in degree mode, is 14.975 miles. Okay, so in our picture up here, this length of side A here will be 14.975 miles. Okay, which now will allow us to actually find that altitude, because at this point we know, we can look at that right triangle again that I was just looking at. Okay, so this one here. Still trying to find that length of side H. We know this side here now, so we can use a trig ratio in a right triangle to help us solve for it. So here we can do, I think we would do sine of 15 degrees because the side H is the opposite one over the length of the hypotenuse is 14.975. Can multiply by 14.975 on both sides of the equation. And these will cancel. When we do that, we end up with H equals 14.975 times sine of 15 degrees. Plug that into our calculator. looks like we get 3.876 miles. So that UFO is flying a little high there, 3.876 miles, which tells us it obviously has to be a flying saucer, right? I mean, what else could it be? Couldn't be anything else. Okay. One more thing that kind of relates to this that might help on some of your homework problems is reviewing properties of parallel lines cut by a transversal. So here in this picture, you can probably tell that this line here is parallel to this one here. And then there is we call it transversal going through them, basically a line that cuts through both. And notice when that line does that, it creates some angles, right? So there's angle 1, 2, 3, 4, 5, 6, 7, and 8 here. And it turns out that some of the pairs of these angles here are congruent, or are the same, based on their positions. So as you might be able to see in the picture, actually, the measure of angle 1 up above is the same as the measure of angle 5. The measure of angle 2 is the same as the measure of angle 6. And the reason for each of those equalities is because if you notice like where 1 and 5 are and 2 and 6 are with relation to the line that they sit on in the transversal, 1 and 5 are kind of in the upper left of the little diagram. 2 and 6 are kind of in the upper right on their lines. If you notice, 3 and 7 are in the same position, so we know the measure of angle 3 equals the measure of angle 7. And 4 and 8 are also in the same position, so we know measure of angle 4 equals measure of angle 8. There's also some pairs of angles within kind of each smaller group that are the same, right? So for example, you might be able to tell that angle 1 and angle 4 are the same. Those are what we call vertical angles because they're across from each other. Same with 2 and 3, 5 and 8, and 6 and 7. And so that gives us even more equalities across the two groups, right? Because if angle 1 is equal to angle 4, and angle 4 is equal to angle 8, well, now we know that measure of angle 1 is the same as the measure of angle 8. And you could find more equalities if you explore this some more. Okay, so again, that might be information that could be helpful for your homework. All right, thanks for watching.